I'm Myth.
What's up, guys? I'm Max. I'm just joined him because he said he was looking for people to join his podcast, and I guess now I'm here. All right.
Yes, thank you for being here, Max.
All right. Could you just tell me a bit about how does this general thing work? I know podcasts, but any structures you guys have got here on the channel, or
in Guide Space Podcast, for every episode, we just have like a sort of common theme, and the podcast generally ends with something totally different from the common theme. It just progresses as a natural conversation, and we just end it where it gets stale. It actually never gets stale. I was filming with my brother for the first 4 episodes, and it's usually when my brother has to go or mom calls us. It's something like that most of the time.
Oh, so you're telling me this is only your fifth episode?
Yeah, that's right.
Oh, I thought this was like a long running thing. I'll be real with you.
It is long running. It's just the 5th episode. I've been running this for 2 years now. Yeah, it's an episode per 6 months, something like that.
Oh, interesting. All right, yeah. So, you want to give the viewers some context as to where we are right now?
Where we are right now, we're at Ewald. Yeah, I think.
You're not gonna say what Ewald, very general, just leave it there.
I think those who know.
We can at least say we're in a dorm common room, I guess. Yeah.
Yeah.
All right.
It's not much worse than my previous recording space, and there's great acoustics in this room. Apparently.
Is there?
There is.
Yeah. All right.
Because there's like carpets, and I know you guys can't see it, but carpets and old walls everywhere, dusty walls. It probably doesn't reflect sounds that much.
All right.
And where we're at has also, just as a fun fact, a great location for stargazing at night. I was very surprised coming here from Istanbul, in a city with so much light pollution.
Us too.
It's like...
Oh, wait. Like light pollution... Explain light pollution for me, please. I'm dumb.
It's just there being, like, uncontrolled lighting, like an abundance of uncontrolled lighting. By uncontrolled, I mean it's like not specifically directed to the ground, so a lot of light.
So like lights just facing up.
Yeah, a lot of light going up, and facing the sky, which makes it really difficult to view the stars at night in big cities like Istanbul. And you can also give us a description of your experience back in Thailand.
Well, but one sec. I know this is completely going off track, but could you just explain to us why, and me as well actually, why light pollution, why you can't see the stars during light pollution? I've heard of it, but I'll be real with you, I don't know the scientific reason.
The scientific reason is just like, if I open the flashlight on my iPhone right now, let me see.
Is it to do with like the thing our eyes take in, like photons / light things?
I mean, if I face the light right here, I find it a bit more difficult to see your face and identify your facial features. So when you have like a big source of photons in the flashlight of my telephone's camera, your eye basically becomes insensitive to other smaller sources of light. And like a street light isn't a smaller source of light than a star, but it's so far away, and a street light is so much more relatively closer. So even like a very small light can completely disrupt your view of the night sky when it's close enough to your eye. And when there are many of those, it can like make certain stars virtually invisible in large areas like Istanbul.
So like because of the distance, it's like just the light essentially is really dim, and like so dim that the
Yes.
point is if you have essentially any light at all, you can't see it. Am I getting that right?
Any light at all? Yeah.
I mean, any light at all.
Yeah. You can't like completely control lighting and artificial lighting. Humans
fair
do.
enough.
But like it makes a huge difference. So in the like even if it's uncontrolled, here in New Hampshire, there's like I don't know, a few street lights, a few room lights coming out of windows, and outside of that, there's not much lighting, so it's very refreshing to be able to see like not just individual stars. Like when you look up in Istanbul or any other large city like New York, you just see like a few like relatively light spots in the sky, and you wonder like what is that? But here, like you can see even like clustered, I think, very well, and it's great for an astronomy lover like me. Which brings me to the topic of the podcast.
Can I wind us off again, please? So yeah, Bangkok, same pollution thingy. But have you seen the stars here? So you have seen the stars, right? You said. I went out biking last week into the woods. Yes. Straight up into the woods, and I looked up, and yeah, that was so beautiful. It was actually peak.
It's actually very beautiful. The same day, I didn't go to the woods, but I went to watch the first soccer match that our school had, and going through not the woods, but just in the fields in front of the academy building, it was also peak, I would say.
Fair enough.
So, Max is actually one of the smartest people ever to talk about with this topic, right? Wouldn't you say so, son?
Yeah.
Absolutely. Right? Absolutely. He's going to the best high school in the world in our hearts, right? And in like objective scale. So I would take what he has to say very seriously.
I would so as well.
I would also say that guys, listeners, ladies and gentlemen, and any other gender that I didn't account for, okay? We love you. Thank you for watching. I know they can be very boring. They are very serious people. But I think that you will learn a lot from listening to them, and that these interviews will someday help you in your future. So, keep listening. Have fun. And also, don't listen to the kid with the MIT sweatshirt. That guy, he's stupid, man. He's dumb. He's like talking to a brick wall, okay? Don't mess with that.
Dude, what is happening?
We just chilling.
Recording a podcast video for...
Come say hi if you want, guys.
Yeah, go say hi.
Yeah. Hello, Evan.
Hey.
Isaiah.
This is a very nice cameo.
Very, very nice podcast, and the best is yet to come. Because we're talking about cosmology today. And Max, I want to ask you.
Yep.
What comes to your mind when you hear the word cosmology?
So, I mean, the cosmos, space, and ology being the study of space, hopefully. Don't kill me, any linguistic people, if I'm wrong. But, so, I think it's, well, the study of space, quite simply.
Very nice observation. That was also what came to my mind when I first heard of the word cosmology. I'm pretty sure. I don't actually know. But it actually has a little more specific meaning. It's the study of the evolution, the fate, and the beginning of the universe. It's like the study of the timeline of the universe. So it's a branch of astronomy, if you will.
Oh, astronomy is the study of stars?
Study of all of space, yeah.
Okay, sure.
And very interestingly, the non-science astrology ends with the science extension logy, which confuses a lot of people, and I think it's due for a change as well. But cosmology also has that extension, and it's the study of the life of our universe.
So today's specific topic is cosmology.
Absolutely.
It's a very wide topic. I assumed we would be digging in specific, but is like, okay, sure, this is how we run things,
This is how we run things, but we are going to get into very specific things.
Where do we start, I guess?
Where do we start? We start at the beginning. Makes
Fair
sense.
enough. Chronologically.
We start at the start of the universe, as it makes sense, right? It makes sense to start at the start of the
Makes
starting.
sense to start
It's-
at the start.
Guys,
Wise words by
it's very
Assad.
disappointing for them. So, Assad, I think future notes for these episodes, right?
Yeah.
Maybe don't record it on a laptop.
Future notes.
That's
Don't do it in the common room. There's too
Right.
many people messing about.
But I would also say, what are you guys talking about right now?
We're talking about the evolution, the fate, and the beginning of the universe.
Okay.
You want to join us?
So mostly the fate then, right?
Yeah.
So, okay, have you gone into religion yet for the start?
We haven't
No.
started because y'all have just been.
Oh, you guys just started? I thought you guys have been here for like an hour.
And,
No.
It's
Huh?
been like 15 minutes. Or
That's
so.
good. We made their episode more entertaining, right, guys?
Yeah.
Yeah.
Right?
For sure. All right.
You're the owner of the
From
channel.
what's your phone?
I'm only
Yeah,
here
it's
for
my
a
phone.
feature.
Yeah.
Mm-hmm.
That's very interesting. Yeah.
Very interesting.
Guys, you guys will learn a lot. I think you guys should talk about religion because that is a very interesting connection to the end and beginning of the universe.
Yeah. We might talk about that, right?
Isad, are we cutting the sections of people being here?
If you want to.
It's up to
We'll
you.
see,
If you
we'll
think
see.
it ruins it by people walking around.
Yeah.
We'll You know when we might move up to your room at some point.
Yeah.
I think it would be a good idea. All right, though.
Yeah.
Go on.
Yeah, I just want to hear your thoughts on the start of the universe.
All right. So
How did the
what
universe-
I've learned
Yeah.
as a basic guy, I would say so. Just basic guy, not much experience in. What's the title of this channel called again?
Assad?
Like the podcast title of the
Oh,
podcast.
Guide to Space.
Guide to Space. I like as much as I've learned from space is what I've learned from classes in school. But I can tell you this much. So, there's the Big Bang Theory, and that's the main scientific theory of how the cosmos, universe, whatever word it is, started.
Yeah.
And then it exploded into pieces, and the pieces flew around and expanded. And the pieces started clumping together into planets, and then planets had materials that made living things like us. Or some don't, but it's rocks smashing into each other and creating planets because of heat friction, I think, and then they melt together and become planets. And suns are from stars, not suns. Stars are from nebulas, something, gas clouds, whatever.
Yes.
Am I right?
You're right.
All right.
Mostly. That was a very sophisticated explanation of the universe. So, thank you for that. And yeah, that's basically the Big Bang. It's the universe starting from an infinitely dense, infinitely small point in 3D space and exploding in huge and releasing tons of energy in the process. Mainly in terms of heat energy, and as you said, matter. Some matter.
Matter's the fancy word of when you don't want to say things and stuff. All right, yeah.
Some things were attracted by gravity to each other, and there was like small, very, very small inconsistencies in that huge explosion, which formed into there being some clusters and there being some huge voids of empty space, huge blanks in the universe as we see it right now.
There's voids, there's just open gaping holes in
Exactly.
this place thing
Yeah.
we live in. All right.
There's like light years cubed of area of space with literally no molecules in it.
I know what light years mean, but you want to just define light years quickly for
Yeah,
us?
light years is a misleading term, if I do say so myself, because it looks like a measure of time because it
But
has
it's
years
a
in it.
measure of distance.
That's right. It's the distance it takes
Light.
No.
The distance light travels in a year. And as you may know, light travels pretty damn fast.
Exactly.
Like, from us to the moon is 8 minutes, right? For a light to travel from us to the moon or vice versa. Do you know that?
It's.
Or am I wrong?
I mean, it's not too wrong, but I think it was 4 minutes to Mars. We'll check.
All right,
Double
we'll
check.
check.
I know it's it in 1 second. Light can travel around the Earth 7 times. So, and distance from the Earth to the Moon is around 30 Earths on average.
Yeah.
So it's probably 30 divided by 7, or even less than that, because the distance from the Earth to the Moon is 30 Earth diameters, and light goes around the Earth in a bit more than it's a bit more distance to go around the Earth than Earth's diameter, because it's the circumference of the circle that is the equator. So
Equator?
equator, yeah. Equator is the way I like to say it.
Oh, interesting. All right, yeah.
Equator. It sounds like Spanish. It is.
It does sound very, Ecuador, the country,
Ecuador, yeah.
very similar, just a T and D away from each other.
Mm-hmm.
All right, yeah. So, when you said there was an infinitely dense point in the 3D space, can I ask you why you said 3D? Like when you were saying how the Big Bang started and all.
Yeah, so
Or does it make a difference, or are we just saying 3D? Why,
why 3D? Because there wouldn't be 3D objects if the universe was in 2D, right? Like a 3D object would not exist in its full form as we think stars and Earth and the objects we observe do in the 3D universe we live in. But it's actually not very defined what the dimensions of the universe was before the Big Bang, which the start of the universe is very dependent on the end, which is kind of the reverse of one of the
dependent on the end.
Yeah, one of the mottos of our school. It's kind of the inverse of that. The end, the beginning depends on the end. So we'll get into those, the fate of the universe, the ultimate end or continuation of the universe. There are a few theories. One theory is the Big Bounce, where the universe, exactly, it expands and then it collapses and then bounces to a new universe. So it expands. We don't know where we're at in that expansion, but it expands to some extent, and then it collapses to an infinitely dense point. Sometimes that definition varies. It's sometimes not infinitely dense point like a mathematical point. It's just very dense. But some physicists say it's infinitely dense, literal zero-dimensional point in 3D space.
All right, yeah.
So the definitions vary on that. But the Big Bounce. So yeah, if we're taking the Big Bounce as the likely scenario for the end of the universe, then yeah, there would probably exist a 3D space even without the universe just exploding. There would be just empty void, and then it would collapse and then jump. But in theories that don't believe in this, they say some theories suggest that the entire universe did not have 3 dimensions. It was just a zero-dimensional point. So the Big Bounce, there's a zero-dimensional point.
Okay, you're starting to
Yeah.
lose me. I'm starting to get confused, but okay, yeah. So just first off, how many main leading theories are there for the end of the cosmos?
Okay. There are 3 leading theories.
3 big
Yeah.
main theories that are supported by evidence?
Yes.
And
Evidence,
so,
mostly like
Evidence,
let's
right?
say educated
Educated.
speculation.
all right, just
Nah.
educated guess, but more fancy. All right, okay, yeah. So we have the big bounce. What's the second one?
The Big Bounce is actually like a subtitle of the big the wait, what's his name? It's confusing. all of these with big in their name. So let me just count them out one by one, then I'll get to the Big Bounce. There's the Big Rip. There's the Big Freeze. The Big Bounce. Just one second, actually. I have to Google this.
All right, what's up, guys? I guess we're here, and yeah. What should I talk about in the meantime? So, Isad, is the universe expanding or the opposite right now?
Currently, it's expanding, and
I can, yeah, just keep searching.
its speed of expansion is increasing.
Oh, it's increasing.
Yes, so it's
Interesting. So yeah, I would want to know why scientists would believe in the big bounce if it's increasing. But
yeah.
like the reason we know it is because of the Doppler effect, right?
Okay, I found it. The reason we know the
The
expansion
reason,
of the universe.
yeah, is it because of the Doppler effect? I've heard of it.
It's because of very poorly defined. I want to say matter, but it's not actually matter. A thing, thing and stuff is more appropriate here because we don't know if it's actual matter. Is what they call dark energy. Dark energy is basically something that has not been observed yet. It's just something like it's like X in maths. It's like a placeholder we add because we see some effects of it, right? We see what dark energy does. Dark energy is just defined as the thing that makes the universe expand faster, right? And
So,
we
what?
see that the universe
Okay,
is
alright.
expanding faster, and we have not yet observed something that would do that with like the classical modern physics. There's like no subatomic particle or anything that would cause the universe to expand faster. So we just created something called dark energy to just fill in that gap in science right now.
So there's just something we just don't know about, and that's somehow explaining why our universe is expanding.
Basically, there's
Okay.
so
I'm not so much following. I'll be real with you.
I mean, so we know the universe is expanding, right?
Yep.
Do you have any idea on why it expands, why it's expanding?
No, because I mean, there are two options from what I understand. It's either it's dense, so it's pushing them out, or but what I would believe it is not as dense anymore, and gravity should be pulling everything closer together. At this point, you know what I mean?
Yes. So that would be that's what we would expect, right?
Yeah.
There's matter scattered around the universe, and like because of gravity, and they get closer, right?
Yeah, so how would the Big Bang have gone out? Because considering, density-wise, it would have just all stayed in one point. Or because of gravity.
So, as I said, that's what scientists would think it's happening, right? But we can see that it's not the case.
All right.
That the universe is expanding, and its expansion is getting faster. We can look at the cosmic microwave background.
All right.
Do you know what that is?
No.
No.
Yes.
So
Just give us a TLDR.
So it's a map of the universe, the entire observable universe, in microwaves. Was it a collaboration between telescopes or the Hubble telescope? I'm not exactly sure.
Hold on, microwave.
Yes.
Like those things where I put my Pop-Tarts and
Yeah.
my ramen in.
Exactly. Not actual microwave in terms of the device. Microwave in terms of where it sits on the electromagnetic spectrum. Like,
Alright,
we
yeah.
have visible light, infrared light, microwaves, radio waves.
They have different frequencies, right?
Yes, exactly.
And the microwaves we have are just shooting the microwaves into the food to make
Yeah.
it warm?
To accelerate water particles inside of the food.
Accelerate.
Yes.
Oh, you accelerate so you add kinetic energy to it?
Yes.
So,
So that increases the entropy of your food.
entropy? Okay, so from my understanding is microwaves shoot in, it makes your water,
The water
move.
particles in the food.
Just the water?
Exactly. I actually
Or just makes everything move?
I'm not sure if water is literally the only particle that is affected, like out of all the molecules that we could construct out of the elements on the periodic table, but out of like basically every food, water particles are mainly what's getting accelerated. I think I know
We
that.
can try it with a completely dry thing.
Yeah, with a complete, and it actually many people do, and it comes out like cold. If you eat from a microwave, it's not like something. It's actually slightly different from if you just plop your food into the oven, and you can see the effects of this.
You can taste it differently.
Yeah.
And like so, just basically, the microwave shoots in. It speeds up the water,
particles.
and so it's kinetic energy, and
Yeah.
it just and it bounces around, and the bouncing around is what makes heat.
Yeah, and
And
basically that's basically what heat is, right?
Yep.
Particles moving more chaotically or faster, and when it's 0 degrees Kelvin, they don't move. They're static. And so the cosmic microwave background is just named because it was measured, it was observed in microwaves. We use infrared light. James Webb Telescope uses infrared light a lot.
Oh.
And infrared light actually can tell us like the composition of asteroids, planets far, far away, because it can give us like a heat map of an object, and different elements and materials have different heat transferring properties, so we can like make assumptions if this asteroid is constructed out of like platinum, or let's say just carbon.
So
So the cosmic microwave background. What was I saying? Why did I bring up the cosmic microwave background?
how we could tell the universe is
Yes,
expanding.
the cosmic. Yeah, you were going to say.
So it's increasing when.
Yes.
How so? What were the three leading theories again? Sorry, the Big Rip, the Big Freeze, and
Big Crunch.
Crunch.
Big Crunch just says the Big Crunch just says the universe will eventually gravity, the force of gravity will take over, and the universe will collapse into a dense point, just as in the Big Bang. The Big Bounce is an extension of that, saying
alright,
there
yeah.
will be a new universe and a new universe and a new
Okay, yeah.
universe.
So, I mean, I assume the viewers would understand gravity, but just basically it's big thing with big thing pull big thing closer. Right?
Yeah, basically that's what we can observe. But I mean, everything in the universe. Let's say not everything. I'm going to use the more scientific term. Matter in the universe. Every matter exerts some sort of gravitational force. It's just much more observable in the scale of planets and solar systems, right?
Yep. All right.
So those were the theories.
Okay, cover the Big Rip and Big Freeze, please.
Okay, absolutely. So I'm going to start with the less violent one.
Violent? All right. Interesting. I wouldn't think cosmology, astrology podcast would go to,
Astrology podcast.
which one is it? I don't know. Stop bombastic side-eyeing me, but,
Okay.
which one is it?
It's an astrology podcast, so.
Astrology and astronomy are different. My bad.
Yes, no problem.
Wait, which one is are you a Gemini sort of one? Which one is that?
That's the astrology one.
Astrology. Alright, my bad. So, whichever less
Yeah,
violent
yeah.
one is start with
I
that,
mean,
shall we?
what can be like possibly more violent than the death of the universe, right? Like if you were
Oh yeah, speaking of death of the universe, I've heard the heat death of the universe.
Yes.
I've heard that term.
Yes, that's
so
exactly
the end
Big
of the
Freeze.
universe. Okay, so
those
cover
are
us.
interchangeable. Big freeze and the heat death of the universe, like freeze and heat death. Freeze is related to heat, obviously.
Oh, so heat death is like no
Freezing.
heat.
Yes, freezing.
I thought when I just heard the term flying around, I thought something like our universe burns up or something, you know? Because but okay, explain heat death, please.
Heat death of the universe is basically the opposite of the big crunch. It's just gravity does not take over. What we call dark energy, or the speed of the universe's expansion, gets faster and faster, and it accelerates, and it just expands and expands and expands, and after so long, basically, matter is basically the matter density of the universe is zero. Basically, it gets exponentially closer to that. Like it expands so much, there's like you wouldn't find an atom in a billion years if you search for it. It's something like that.
So it's very, very far away, but it's possible if it keeps expanding, right?
Exactly.
Yep, and so everything also doesn't move because it's frozen.
Everything like it expands so much, and
Like nothing's colliding into each other anymore.
Nothing's colliding to each other. It's just void, and there's no action going on in the universe. It's pretty much static, and there's pretty much no particles to even contain any sort of energy. So that's what's called the heat death of the universe, or the big freeze.
Fun. Sounds very depressing.
And for
Just void. empty void. Just like my love life.
But-
Empty void.
but some physicists still think there will be a new universe after it expands so much. So this is kind of like when we're looking at the start of the universe, right? There's either like space-time, literal dimensions of the universe expand. So like from a zero-dimensional universe.
Okay, the dimension thing is getting.
Zero dimensions is basically just a point.
All right. Yeah. Okay.
One
Yep.
dimension is a line. You just extend that. 2 dimensions adds
It's a photo, just like
Yes.
this video.
Yes. 3 dimensions adds height to that. And makes up the 3-dimensional world that we observe and live in. We don't observe in 3 dimensions, but we observe in 2 dimensions, the 3-dimensional world.
Yep.
And there's the theory. I'm sorry.
I think dimensions is like a really convoluted thing that would be its own topic, or
It's very on topic, because when we're looking at the start of the universe, it makes a huge difference if, let's say, I'm going to cook up an analogy really quickly. Let's say there's a popcorn, right?
okay,
Flying
popcorn
around.
kernel or popcorn.
Popped popcorn.
Okay.
Popped popcorn flying around this common room, okay?
One singular.
Yes, one.
Yes.
And that's basically analogous to the infinitely dense point of matter in the Big Bang.
All right. Got
So-
it right here in my fingers.
One theory is that that popcorn is flying around in an empty room. In the other theory, that popcorn is the room. There is no void. That popcorn is the entirety of space in the universe. And space in the universe comes to exist as that popcorn explodes into the Big Bang. In the other theory, the popcorn expands when there's already space and void there. It just expands and fills up the gaps.
Okay. Yeah. Sounds like a lot. I'll be real with you.
So, if there is a room, even without the popcorn, then the big freeze can be followed by another Big Bang, without the universe having to collapse into a zero-dimensional point.
Because something else could affect it.
Yes. Yes.
Because we don't know. Also, like,
Mhm.
in theory, we could be, like, smaller than quarks, and then there's just
No.
humans. We're just a quark, and,
Mhm.
or, like, the smallest thing we know, and it's just humans around us.
Yeah.
And it's just the same thing, but it's just God's looking at us, but gods don't even know we exist. You know what I mean? Am I getting this right?
Okay.
Like, the size, there might be just stuff we don't know
Mm.
exist. Yeah, so that was actually going to be my question. Like, how do we know that our planets aren't just like atoms to something else? We don't.
You don't. We don't.
Hey,
So,
all right.
coming back to the observable universe.
Yep.
The observable universe and the cosmic microwave background suggests it's around 90 billion light years in diameter. And
90 billion.
uh,
How old is the universe?
it's largely considered to be 13.8 billion years.
90 billion.
Yes. So
Sorry.
okay,
What?
it comes to one of my favorite points that I was just dreaming of when thinking about this podcast episode.
All right, go on.
So, how can the universe possibly be 90 billion years on diameter?
If it's how many years old again?
13.8 billion years old.
90 and 13.
Yes.
So, can I have the how many times that is, please? My math's not mathing today.
I don't know, it's what, 7?
6. No. Okay, let's
It's
just say
closer to
6.5. 6.5
Okay.
it is. We're not saying that number. Alright, yeah, so like 6.5 times faster
So,
than light.
how can the universe's expansion be faster than light itself, right?
Yeah, that's just weird, but okay, yeah, go on. Please,
Because-
I want to know now.
Because we know light is the fastest thing in the
Thing.
universe. Or matter.
It's
not.
fine, I don't mind.
I have to find something between thing and matter. It's the.
Substance? No, that's even worse.
It's.
Just say
It's,
thing, it's
light
fine.
is not actually matter because it doesn't have mass.
Yeah.
The mass of a proton is 0. So I can't call it matter. And I can call it thing, but that may be too ambiguous because it may include like I don't know, other things like the expansion of the universe. Let's say a new category that I call apple, right? It's something between thing and
It's
matter.
semantics, Rose. It's fine. Just
Okay.
Semantics.
Something between thing and matter is this apple. It does not include the expansion of the universe, but it includes light, okay?
By the way, I have no idea where you pulled that apple from. It's just
It was just sitting on the couch.
slash spawn apple. But yeah, go on.
So, the expansion of the universe is not actually matter. And
What do you mean?
the expansion of the universe is not matter, and it's not an apple.
Sorry, what? No. So, no, because that just doesn't grammatically make sense. The expansion of the universe
Is not
is
matter?
a process. But, like, the thing that's
Yeah.
expanding the universe isn't matter, or what are you trying
Exactly. That is also true. But, I'm going to make the blueberry muffin analogy, okay?
to say? Alright. Blueberry muffin.
Think about a blueberry muffin when you're first throwing it into the oven. How does it look like?
It's way flatter than when it expands in the yeast.
Yes. So blueberries in this case,
Very soft,
Mhm.
just flat, liquidy.
blueberries in this case are matter. Okay? Matter in the universe. And the dough is the fabric of space-time.
Fabric of space-time.
And when
Alright, just keep going.
When I
Slowly,
slide
please.
that into the oven, the blueberries themselves don't move. Like, they don't go farther away from each other. The space between them expands. Right? So, because the space between them expands, it's not constrained by things like matter in the universe are constrained, which is the speed of light. Matter in the universe cannot be faster than the speed of light. But
So this space that's expanding
yes,
isn't matter.
it's
and
not.
it isn't a thing. It's somewhere in between. It's something we don't
It's-
know.
I still call it a thing because
Yeah.
everything is a thing.
Yeah, do we know it or do we not know it?
It's just not an apple or matter.
Like, have we found out anything about it at all? No. Is there a name
It's
for
basically
this
just
thing?
space. Space.
It's
There's, I mean, Isaac Newton's outdated theory of the universe. There you go if you want.
Isaac Newton. Right there.
Okay.
Oh shit, that actually hurts.
And Einstein's
That was a horrible idea.
fresh theory of the universe, including the space-time fabric, thinking of space and time as a dimension. So when we think about it like that, you can't think of it like mathematically or geometrically. Like, let's say just it's a plane.
What was the point of this again?
This is the point.
What were you trying to explain?
You asked what is it, right? What is it? Expanded.
Yeah,
right?
no, like, what do we know about it so far?
What do we know about the expansion of the universe?
The
Or-
thing that's making us expand.
Oh, dark energy.
It's just called dark energy, and that's
This
that's the dough in your analogy.
Dark energy is like the baking soda.
Oh, it's the thing that's causing the expansion.
Exactly.
However, the thing that's expanding
Is space time. It's
space.
yes.
Just good old space. All right.
So
And that's why we've expanded more than that. All right. So universe has existed
13.8 billion years.
billion years. I just searched it up. Earth
Yeah,
was
there's
like
been recently
4.5 billion years old.
Earth.
So we've been here for like 40% of the time.
we've been here.
Not we. Earth itself. We have been here for very little time.
I mean, we have been here for quite long, right? 5 billion years is very, and it just speaks a lot about the I guess the continuation and like the lifetime of a planet, right? It's not this fragile thing that just gets that just clash into each other and just explode day in and day out. Space is much larger than we think it is and give credit for, and you can understand that after watching a previous video of mine. The vast size of our universe and extraterrestrial life. The presentation I made back in 6th grade.
No. Okay.
Yeah, if you're into the vast size of our universe, I would recommend watching that video. It's a great resource for students.
Shameless plug. I like it.
If you don't believe in what you do, why should other people believe in it?
Yeah,
right?
fair enough.
I always like my own posts.
All right.
Right.
Well, what else have we not covered? The Big Rip. That's one of the things. we
Yes,
covered.
that was the more violent one, right?
Oh yes. Let's get to the juice. Let's go. Why is it more violent?
So, it doesn't freeze. It gets ripped apart, right? So,
Or how?
that's like the thing this depends on. Like, how do we decide if the universe is going to end in a big rip or a big freeze, right? That's the underlying question here.
Yeah, but like, how does it? Okay, what is the reasoning and the belief
Yes, I'm going to get
behind
into that.
the
In the
Rip?
big freeze, in the big freeze theory, the universe's expansion doesn't have to get faster.
Does
if-
it have to get faster?
Yeah, it can
Oh.
just expand at a constant speed, and there
Alright,
could
yeah.
be a big freeze.
Oh. I'm just gonna go off a limb here and guess what the big rip is. Is it expands so much that at some point it just rips apart because it's so fast?
Yeah, the
'Cause you said
expansion of the universe gets faster in the Big Rip. So
It's
the speed of expansion of the universe isn't a constant like it could be possible in the Big Freeze scenario.
because like big freeze is like it doesn't matter.
yeah, it's
Even
a
if
Big
it
Freeze is
slows
a
down,
linear
it'll-
equation. Yeah,
Yeah.
And the Big Rip, it's the expansion of the universe accelerates, and it gets so strong. The dark energy, the thing that's making the expansion of the universe faster. So we just slipped a bit too much baking soda into the muffins, and it just started ripping away atoms and subatomic particles, and there's literally nothing in the universe anymore. Everything is ripped apart.
Fun. All right. So
Yeah.
what else have we not covered?
We have covered.
Leading, starting theories, present things about a present.
Yeah.
And
We have
the
covered a
end.
lot.
We've got it all. We missing anything
Are we missing anything?
that you want to just really cover? Otherwise, I have stuff to talk about.
You have stuff to talk about?
Well, my question is,
Go ahead.
what out of the three ending theories, what do you believe in, and what is the one disbelieved in the most? Well, let's start with what you think it is,
Okay.
or whichever one you want to start with.
Yeah. Which one do I believe? So, let me give like an introduction to the current landscape of what scientists think about this. The theory that got less common and kind of less believable is the Big Crunch. Like,
Because it's increasing.
yes, like
All right, yeah.
we did not like why if it's increasing and it's increasing faster, why would it stop increasing and get together?
Because why would it increase? Actually, why is it increasing?
So let's just clearly define what we know. So we know it is increasing, but we don't know why it is increasing.
Oh, we don't. Okay.
Yes.
All right.
We don't know why it is increasing. We just know we just because we don't know it. We just coined this term called dark energy as a placeholder for.
Oh, so
That
dark energy is just
we
a
have no
thing
idea
that
what
just
it is.
makes it expand,
Yeah.
and that's the thing. The thing we don't know what it is. We're just calling dark energy for the time being.
Yes.
Is dark energy and dark matter the same?
No.
Is that just a completely different thing that I'm
Yes,
getting?
exactly.
All right.
Completely different thing, and I will
We can
explain
get
the
that
difference.
on a different day, or you want to explain it now?
Dark matter is not really. It's not a lengthy topic. It's just. It's again a placeholder for what we don't know.
All right, we love this sort of stuff. Go
When
on.
you hear the word dark in cosmology or astronomy, it basically means you don't know anything about it.
So like it's in the
Yes.
dark.
Yeah.
All right.
Dark energy is a placeholder for explaining why the universe is expanding. Dark matter is for some other things, like galactic behavior. If, like, through the lengthy calculations that are done with current-day classical modern physics, our Milky Way galaxy and other galaxies should not be behaving in the way that they are. They should be like flying and breaking apart, and like they should not be like rotating in this stable form.
Yep, orbiting around
Yeah.
stars and stuff.
Like at the stellar scale, it's like easy to explain. We can like our calculations are pretty consistent in the stellar
There are
scales.
different scales.
Yeah.
Just name them.
There's the laptop and us scale. There is the
Planetary scale or no?
planetary scale. Yeah,
It's just not defined clearly, but
yeah. I mean, you can like pull up
Yeah,
scales,
fair
whatever you
enough.
want. Planetary scale could be like distances inside of the solar system, which is much smaller than the interstellar scale. which is the distances between stars, which are at least a couple light years. The
How
closest star we
close
have
is-
is 4 light years away.
What's it called? And
I'm not into
something.
astrology, so I don't know much about stars themselves, actually.
Oh, really?
So,
Huh.
Yo, do you know it's on duty?
there was the poster for the faculty, but they took it away. On Saturday nights,
Yeah, I guess so.
is it Senor on Saturday nights?
Bro, is TS not like busy, bro?
Is it Senor on Saturday nights?
No, so it looks changes around. I don't know.
Okay.
Yeah, guys. So
I know.
wait,
No,
guys.
No worries, no worries.
Oh, okay. Alright. It's fine
We,
then.
we can actually,
We're just recording a podcast.
just
We're
recording.
almost done, but
no
Yeah.
problem, no problem. Just
we'll
we
just
would,
cut this part.
we would
probably,
appreciate
right?
it.
Ow.
Awesome.
So where were we?
Where were we?
Before we, we
Yeah,
just got
at the
interrupted.
scales, right?
So yeah, the scales going. Yeah.
It was 4 light years away. It was, I think, Alpha Proxima
It's fine.
Proxima
Oh,
Centauri, something like that.
Well, 4 light years away. Still.
Yeah, Proxima Centauri. Yeah,
Yep. All right. And yeah.
is the 4.2 light years away. You're basically not reaching it.
So.
You're not reaching it by traveling with matter. But thank you, Einstein. There's something called wormholes.
Ooh. All right. Well.
That
Anything.
So wormholes aren't they aren't related to matter traveling at speeds like we do. It's about bending the fabric of space-time. So like think of space. If you think of space as like a 3D Desmos graphing calculator,
3D Desmos. Go on.
you can like do transformations on it and like warp like the shape of it, right?
So you just do transformations on the space.
Yes.
Good old.
And that's not actually very
space
difficult
itself.
to do. You know, you and I also do that right now.
Oh, because we're translating?
Every matter
When
in
I
the
move
universe.
my
Like,
hands?
have you seen those general relativity demonstrations where they drop like a star or like a heavy object in place of the sun on like a file, a fishnet or something, and then the fishnet like lowers and bends?
Like, you know,
Yes.
all those, like, models that, yeah, I
So
know what
because
you
of
mean
its
now.
mass, everything bends space-time. And black holes rip space-time. They don't just bend it because they have infinite mass.
Oh, because it just pushes down
Yes.
so badly that
Yes,
everything...
exactly.
Oh, that explains so much.
And
Alright, yeah.
we are not sure how to do it, but there's like nothing preventing wormholes existing, which is like just there's like this star 19 billion light years away, and then there's our star. We can't like reach that in a reasonable time with like just a spaceship or something. So we just in some way connect those pieces in space, like connect the lattice points in 3D geometry, and then we can like just shorten the distance, right? Like I don't have a paper right now. If
It's
I had a
fine.
piece of paper, right, like let's say a triangle like representing space. It's just me folding the triangle so that like this point is let's say Proxima Centauri, this point is our sun, and this is space-time. It's like you do some sort of transformation in the fabric of space-time where this point falls on the sun or gets really close to it. So instead of like traveling all the way through here, you just travel here. So that's basically a wormhole.
Alright, yep. So, you want to just do a quick summary of what we've covered so far and end it there?
Mm-hmm.
Or you want to just end it there? Up to you. Do you usually summarize stuff?
Yeah, let's just have like a.
Okay, so...
It was what do I think how the universe will end, right?
Wait, let me try and summarize it, and you correct me if I'm wrong.
Okay.
So, to see if I've actually learned anything, or
Yeah,
if I've just
absolutely.
been blanking out completely.
You can watch the episode. It's going to be released on YouTube for millions and millions to watch.
I mean, already been millions and millions, huh? Alright.
I said hopefully.
So, the leading theory for the start of the universe is the Big Bang, which it's like a really condensed point zero dimensions. It's just 1 point, and it's expanding. And because it's really dense, it's expanding. And the thing that's causing everything to expand is this dark energy, which we don't know why it's expanding, and it's pushing all the stuff out, and we're expanding and increasingly expanding faster.
Yes, right now.
Yes,
With
and
our observations
we
right
know
now.
that because dark energy.
We know that because of our basic
waves.
microwave, cosmic microwave background. Yes.
The cosmic microwave background.
Mm-hmm.
And the leading theories for the end of the universe is the big rip, the big crunch, and the big freeze. Big freeze is everything moves so far apart that nothing's colliding and nothing's happening.
Exactly.
In good old empty void, or the heat death of the universe. The big rip is it's increasing so fast that everything's apart, and the big crunch is gravity at some point takes over, pulls everything back in, and pulls back into one starting point, and that's it.
Exactly.
All right, see you guys next time. I'm not sure when we're gonna do this again.
See you guys in the next episode of the
I still can't remember the channel name.
Guide to Space podcast.
Yes, that thing. Ta-da!
Yeah.
All right.
See you later, guys. And I promise it's not going to be at the end of the universe. It's hopefully going to be in a couple weeks or months or years.